Okay, let's take a look at this question. They want to know, you're trying to reduce the probability that you'll get a type 2 error, and they give you 3 choices here. You're reducing a type 2 error, and so you have a 0.01, 0.05, or a 0.10. So we got to pick between one of those. So let's first of all take a look at what exactly is a type 1 error and a type 2 error. A type 1 error is the incorrect rejection of a true null. So here it's where your null is actually true in reality, but you incorrectly rejected it. And a type 2 then is probably going to be just the opposite, right? It's when you fail to reject when something is really false. So you should have rejected it, but you didn't. So let's take a look at, maybe we can make a little more sense out of this, because it's kind of, can be a little bit vague. So let's see if we can get rid of this. And let me just type in, there's only 4 things that can happen, right? You can either correctly accept the null, or you can correctly accept the alternative, or you could make a mistake. Either way. So that's the 4 outcomes, and let's label them here. So really you have the hypothesis is really true, so this is the reality up on top, and the other outcome is the hypothesis is actually false. Okay, and then over here on the side, let's say this is your decision over here. So your decision would be you can either reject the null, or you can keep the null. Keeping the null or rejecting the null. Okay, so there's 4 outcomes, alright? And let's just write this here. Up on top, this is the reality, right? This is really what happens. In this column, the hypothesis is true, and in this column, the hypothesis is false. Okay, so let's see. Let's focus in on the left side. If the hypothesis is true, and you reject the null, you've made a mistake here, right? You've made a mistake. You made the wrong decision. If the hypothesis is true and you keep the null, that's what you should have done, right? If the hypothesis is true, you have to keep it, or you cannot reject it. Alright, let's go take a look at what happens if the hypothesis in reality is false. If the hypothesis is really false and you reject the null, well, that's what you're supposed to do, right? Not enough evidence to accept your claim, so you reject the null. And if the hypothesis is still false, but you keep the null, you've made another mistake, right? So these are where these 2 errors come into play right here. So this is actually a mistake right there. Alright, so instead of just calling them a mistake, they've labeled them type 1 and type 2 errors. Okay, so let's label this type 1 error. So type 1 error, once again, going back to the statement, is when the incorrect rejection, so you incorrectly rejected a true null, right? So here's a type 1. We'll do it in the same color, blue. So here's a type 1 error, right? Type 1. Sorry, my handwriting's terrible. Okay, let's take a look at the type 2. Type 2, once again from the statement, is the failure to reject a false null hypothesis. So the hypothesis is false and you fail to reject it. So here's a type 2. Type 2. Type 2 error right there. Alright. So let's take a look at type 1 errors, and we'll do it over here. We'll do a type 1 error analysis right here. just so it makes a bit of sense. Type 1 error. Okay, so a type 1 error occurs because you rejected the null when you should have kept it, basically, right? So let's take a look at something here. Well, once again, you've got right in the middle of this curve, if I could draw it right in the middle. Let me just draw it with a pen. Sorry, computer's not cooperating. So right in the middle of all of these normal curves, you've got the mean, right? The population mean. And really what we're doing on all these is we're saying, okay, let's say that our threshold, our test that we need to beat, in this case, let's say that's 0.1. All right? And if we make a type 1 error, that means that we rejected the null. Let me go ahead and draw this other side over here. Whoops. So we have 0.1, right? Or 10%, right? The same thing as 10%. 10% over here, right? So a type 1 error is whenever you reject the null, and when you reject the null, that means that your sample mean falls into either one of these two categories over here. It depends on if you're doing a left tail, a right tail, or two-tail test. So if you reject this unshaded part, that's the null, right? And this is our threshold of 0.1 or 10%. So if you reject the null when you shouldn't have, that means that your test ended up in either the yellow areas, right? Well, let's take a look at what happens if our threshold, our test, our alpha is smaller than 0.1. So let's take a look, do it in blue again. So remember, these are my alpha values up here, alpha 0.1. So what if our alpha was smaller, say 0.05? Okay, we still have a population mean center there. And if we have a smaller threshold, that means that this, oops, needs to be over a little bit. Let me erase that and try again. So let's say that our alpha is smaller. That means that this 0.05 is moved more to the right. And likewise, it's moved more to the left on the low side, right? 0.05. Okay, so if we shade it again like we did in the previous example, you can see that now the yellow shading has gotten a lot smaller. The less shading over there means smaller probability of that happening, right? So remember, a type 1 error is whenever we reject the null when we shouldn't have rejected the null, right? So notice what happens. It's less likely that I reject the null because this white space in the middle that I haven't highlighted is getting larger, right? So it's less likely that I come up with a score. Let's say that in my first example, when alpha was 0.1, let's say that my test score ended up right here. And let me make it purple. Let's say that it ended up right here. Okay? Based on that evidence, the probability is less than my threshold of 0.1, so I would reject the null incorrectly, but I would reject it, and I would be accepting the alternative. But if I take the same purple mark and I have a threshold or an alpha that's 0.05 in this case, here, because this purple is in the unshaded section, this would cause me to be less likely to incorrectly reject the null. Okay? So our question is asking about type 2, so let's do the same kind of analysis on our type 2s. Let me roll it down just a little bit so I can see both of these. Well, actually, let me see if I can move it over. If I can just move this over here. So let's move it over here where I can kind of squeeze it into the same spot. Okay, so now a type 2 error, we still have the same population mean right down in the middle, right? And let's use our same alpha of 0.1. So 0.1, put the alpha line right here, right? Somewhere around in here. 0.1, 0.1, and we shaded that in yellow, so let's do it in yellow again. Alright, let's go ahead and draw the second one. This alpha was what, 0.05? So it gives us a lot smaller of a tail, only a 5% chance, right? 0.05%. Okay, shade that one as well too, and then we'll get into our analysis here. Alright, so in our type 2 error, right here, we're keeping the null, right? That means that the center part is winning. And a type 2 error occurs when we keep the null when we should have rejected the null, right? Okay, so let's take a look at it. Let's take a look at an example of this. So here we are keeping the null when we should have rejected it, right? So it might be a situation like this. We keep the null. So here we kept the null. Let's say that we kept the null when it's over here, okay? But we're real close to that 0.05 threshold, right? So because our sample mean, our x bar, since our sample ended up in the purple, on the purple line right here, we decided to keep the null and we rejected the alternative, right? Well, let's say that we had our thresholds bigger. Our alpha here is equal to 0.1, right? And let's use that same purple mark. We'll just transpose it up. And now look what happens. Now, even though we had the same data, because we had our alpha was larger here. It was 0.1 on the first graph, and on the second graph it's equal to 0.05, like so. Then look what happens. So the question that we were asked is, we want to minimize the type 2 errors, right? So we need to make our alpha largest. So the largest choice we have, and this is 0.10, right? So 0.10 reduces our type 2 error probability.